How does oscilloscope probe loading affect your circuit? Imagine trying to listen to a whisper in a quiet room, but someone keeps tapping the microphone. That's similar to what happens when you connect an oscilloscope probe to a circuit. The probe can influence what you see and how the circuit behaves. When you attach a probe to measure a signal, it adds some extra elements to the circuit. These are mainly the input resistance and input capacitance of the probe. Resistance is like a small roadblock for current, and capacitance is like a tiny battery that can store and releases electrical energy. Passive probes, which are the most common, usually have about 9.5 picofarads of input capacitance. Picofarads are tiny units of capacitance. High-frequency circuits are very sensitive to this capacitance because it can load the circuit more heavily as the frequency increases. When a probe is connected, it draws some current to develop a voltage at the oscilloscope input. This current draw can change the signal you are trying to measure, especially in delicate or high-speed circuits. Active probes are designed to have much lower input capacitance, often less than 1 picofarad. This makes them better suited for measuring high-frequency signals without disturbing the circuit too much. To reduce the impact of the probe, it's good practice to connect it to points in the circuit with lower impedance. Also, keeping the ground lead short is important. Long ground leads can introduce inductance, which can cause resonance and distort the signal further. Loading effects can cause the bandwidth of the circuit to decrease and the rise time of signals to increase. This means the signals might look slower or different than they actually are. In timing-sensitive circuits, this can lead to errors or even circuit malfunction. For example, if you are testing a digital signal that needs to switch quickly, probe loading might make it seem like the signal is slower than it really is. Knowing how to choose the right probe and minimize loading is key in electrical measurement. Using a high-quality active probe or a low-capacitance passive probe helps keep your measurements accurate. Also, always try to connect the probe at points with low impedance and keep the ground lead short. This way, you get a clearer picture of what's happening in your circuit without the probe itself changing the behavior. Remember, understanding probe loading helps you see the true signals and ensures your measurements are reliable.